So we're still going to look at the limit here of a rational function, but we have a trick when there are radicals involved, right? And when I say radicals, we're talking about these square roots. So the trick that we often use involves a conjugate. And so conjugate, just to refresh your memory if you don't know what conjugates are, if I had x plus b, then x minus b would be the conjugate. Okay, so a difference of squares, we're multiplying two conjugates. And what we notice when we're multiplying conjugates is that that middle term disappears. So in this case, we have a radical. We're doing the limit as x goes to 0 of the square root of x squared plus 100 minus 10, all divided by x squared. And there's no obvious way to simplify this. So what we do is we use the conjugate. So I'm going to take the numerator and rewrite it as the conjugate of what I see. So rewriting it as a conjugate means that minus would turn to a plus. That's the difference there. Now, I can't multiply by any random number, but I am allowed to multiply by 1. And if I put something over itself, I can make it equal to 1. So in this situation, now when I FOIL my numerator, let's look at foiling that. I have x squared plus 100 minus 10 times the square root of x squared plus 100 plus 10. So my first terms, that would be squaring a square root. I'll get x squared plus 100. Of course, that's the square root squared, but those cancel. So we just have that for my first. Inner, I've got 10 root x squared plus 100. My outer terms, I would have plus 10 root x squared plus 100. And then my last two terms would be negative 10 times 10, I get negative 100. So what we notice is those middle two terms cancel. And when I FOIL this, I get what was under the radical, x squared plus 100, and then I get minus 100. Okay, so let's look at that. We said that this, once I multiply by 1, the numerator turns into x squared plus 100 minus 100. And we have all of that over x squared times x squared plus 100 plus 10. And at this point, another question generally arises. Ms. Stein, why didn't you FOIL the bottom? Well, because I want to leave the bottom in factored form. The goal here is to somehow be able to cancel common factors. And if I multiply that out, I won't be able to see that as easily. So we're manipulating the numerator to get rid of that square root. And what we notice, plus 100 minus 100, those are going to cancel. So I have the limit as x approaches 0 of x squared over x squared times x squared plus 100 under the radical plus 10. And you'll notice now I have x squared over x squared. This leaves me with the limit as x goes to 0 of 1 over the square root of x squared plus 100 plus 10. So at this point, now I can take that 0 value, plug it in to evaluate, and I've got 1 over the square root of 0 squared plus 100 plus 10. And that gives me the square root of 100, which is 10. So I've got 1 over 10 plus 10, or 1/20. 1/20 is the value of my limit here.